All right, we are now recording. We're going to begin from current slide, but we're also going to review now. Let me just make sure. It's been a while. I'm pretty sure we did example 5 in class last time, didn't we? Okay. All right. So I think I'm on the right place. But let me go over these announcements. This one has the potential for being really, really important. Okay? Tomorrow, there will be actually 4 informational sessions. 2 on Bessemer campus, 2 on Birmingham campus. The topic will be the institutional scholarships and summer Pell. Okay? I don't know how many of you may be familiar with Pell, but one student in yesterday morning's class said that he got summer Pell last summer. I didn't know it was happening last summer. It what?
It's because he did part-time instead of full-time. He did part-time instead of full-time.
Okay, that's what I was guessing. But this year, we're doing summer Pell for a while anyway. About, I'm guessing 7 or 8 years ago, they did summer Pell, and it was, from my perspective, a booming success. I mean, we had the best summer enrollment we had had since I'd been here, and it was really great to have it. It happened for about a year or 2, and then it ended. I think midterm elections or something like that happened. I don't know what it was, but anyway, it stopped. So for the last several years, and then before that happened, the institution, the college, tried to get summer scholarship money available. We went to our foundation and lots of other places trying to get some scholarships for summer. And we were somewhat successful, and for qualified students, we're able to maybe provide 1 course for them in the summertime. So we have this pot of money that we've been using for summer scholarships. Well, now we have summer Pell, so a lot of students won't be without funds this summer. They'll have Pell Grant, so they can do that. That opens that money up for a lot more students and maybe for more courses. So whether you're on Pell Grant or not, if you're on Pell Grant, please get that FAFSA in now, okay? Because if you get it in time and they get it approved in time, you can use it this summer. And if you don't qualify for FAFSA, for a Pell Grant, then you can apply for a summer scholarship, okay? It may help just do 1 course or 2 courses or something like that, but we do have some money available. If you want more information about this, please go to one of these sessions tomorrow. Tomorrow, April 4th, the first session is from 11 to 1, okay? And that will be, and then the second session is from 5 to 6:30. Now, they're going to be on both campuses at the same time, so if you're on Birmingham campus, it's then, Bessemer campus, same time. And the Bessemer campus, it'll be on in the faculty staff dining area. Now, where we are here is in this corner classroom right here. Go out the door and go down this long hallway, past the first stairwell, to the second stairwell. Not to the end, but the second stairwell. Go down half a flight of stairs. Go down that first little stair, whatever you call it, there's a name for it, that first set, and then go on to the floor that's in front of you. You wiggle around a little bit there, and then go toward the dining room, but before you get to the dining room, on your left is the faculty staff dining area. Now, as far as I know, no faculty staff, or very few faculty staff, ever eat in there anymore. When I first started here 20-some years ago, it was very popular for the faculty to gather down there and enjoy lunch together, but we just don't do that much anymore. So it'll be wide open, and it's a great space for these informational sessions. And then tomorrow evening from 5 to 6:30, same thing, same place. Now, if you're on the Birmingham campus tomorrow at either of these times, it will be in the Leon Kennedy Center on the Birmingham West campus in the cafeteria. which I found pretty interesting because 11 to 1 is right over the bulk of lunch hour, okay? And they'll be eating lunch in there. Now, I don't know how full it is this spring, but I guess they'll just have a little area off to the side that the meeting will go on. And even the 5 to 6:30, the dormitory or the residence hall students, that's when they eat. But that's a much smaller crowd, so I know there won't be any conflict in space and center. But these are all offered by the Office of Student Financial Services, and they are worth going to if you want to get some financial help this summer. Math team is always looking for good, interested people to participate. They meet Fridays at noon and Monday afternoons at 3 and on the Birmingham West Campus in the Science Building at C Hall C100. We have lots of good tutoring services on both campuses. On this campus, student support services down the hall. That second stairwell I was talking about, don't go down the stairwell, but hang a right, and you'll be right there at student support services. If no one's in there, the lady who used to man that space, she is no longer working here, so you may have to go all the way down to student support services at the end of the hall. I think it's 212 or something like that. Go down the end of the hall, hang a left. It's the last office on the right, and go to and catch them there. Melva's here, okay? And they will help get you lined up for tutoring. If you prefer the Space Center, go to that second stairwell that we've been talking about. This time go down a full flight of stairs. When you get to the bottom, right around the corner, you'll see the sign over it is the Space Center. Now, several of you are very good in math, okay? You're at Math 112 now. You may qualify to tutor math. So please take advantage of that and tutor, okay? Is it Jasmine? No.
It's Glenn.
Huh?
Glenn.
Glenn, got it. Kara. All right. And oh, you're in here.
Mayfield.
Huh?
Mayfield.
Yeah. I went past you. Taylor, right? Okay. Okay. So you can also get tutoring down in the Space Center. But you can also tutor at either places. So if you don't catch anyone in 202 up here, go around to 212, see what you can find out about being a tutor, or go down to the Space Center and see the same thing. So tutoring is available, but also the opportunity for you to tutor is available. Okay. I think I've got everybody marked that's here. 1, 2, 3, 4, 5. Oh, here's Lindsay. Okay. 3, 6, 7, 8, 9, 10. 2, 4, 6, 8, 10. Yeah, double digits. Good deal. All right, any questions on anything we've done so far or any of the announcements? Okay. Let's see. There is one more that I haven't seen the flyers about it yet, but I know it's coming. The Honors and Awards Day is coming up. I don't think it's this Thursday. I think it's next Thursday. I believe that's right. So that's going to be on the Thursday morning. I don't know what time yet, so we'll probably either have a shortened class. We'll probably have a shortened class that day because of Honors and Awards. Okay. Well, if there are no questions on what we covered so far, then we were on the top of page 130, Intermediate Value Theorem. Okay? PowerPoint is so slow today, and it was pretty much yesterday, too. Intermediate Value Theorem implies that if you have 2 points on a curve, A, that's the x value, alpha B is the y value, and B on the x, and alpha B on the y, 2 points, A, alpha B, and B, alpha B, These are 2 points on the graph of a polynomial function. Polynomial function. What can you tell me about the graph of a polynomial function? 2 characteristics of it. Always true. Graphs of polynomials.
Going opposite directions.
Okay. I may have been going opposite direction, but I'm trying to get you. They're always smooth and continuous. Smooth and continuous function. Polynomial functions always are. Other functions may not be. Absolute value function is continuous but not smooth. It has a point in it. A lot of your piecewise defined functions are not even continuous. When you get into trig, tangent functions, not continuous, okay? Sine and cosine would be smooth and continuous. So the polynomial functions are always smooth and continuous. So these are 2 points on a polynomial function that you know has to be smooth and continuous, and your y values, alpha of A and alpha of B, are not the same. If they were the same, then you can't really use this theorem. But if they are not the same, and in this case they're not, here's alpha of A down here, alpha of B up here, okay? Then for any number D that's in between alpha of A and alpha of B, any number that's in between those two, there must be at least one number C between A and B such that alpha of C is equal to D, as is shown here. And it's pretty clear it has to be true actually for any continuous function. It doesn't even have to be smooth, just any continuous function. If you have A alpha of A here and B alpha of B there, for anything in between, there's got to be one place because this is a smooth continuous function. It's a continuous function. So there's no gaps, so anything in between alpha of A and alpha of B must have some value C on the x-axis that alpha C is equal to D. Okay, that looks fairly obvious. Seems like it makes sense. Here's how they express it formally, or a little more formally. Let A and B be real numbers such that A is less than B. So A is over here, B is over there. Okay, if F is a polynomial function, meaning smooth and continuous, such that f of A and f of B are not the same, okay? If it happen to be the function, they all sorts of things, but these two values, they were the same, you can't really use it, okay? Because there's no D in between, okay? But as long as they're not the same, then on the interval from A to B, f takes on every value between alpha of A and alpha of B. Every value. It's not just one value, every value between them. Now, sure, it can take on some values above alpha of B or A and below either one of them. But it will take on every value in between. Sometimes more than once, not necessarily, but sometimes more than once. Jay, all right? Okay. Anyone else come in since I called roll? Okay. So the intermediate value theorem helps you locate real zeros of a polynomial function in the following way. If you can find a value when x is equal to A, at which the polynomial function is, say, positive, okay, and another value, x equal B, where it's negative, you know there's got to be a zero in between because it takes on every value in between, okay? You can conclude it has at least one real zero between A and B, okay? Now that works if A was negative and B is positive. You still are going to have at least one zero in between. Okay, and that's what we're doing in this section, is finding real zeros of polynomial functions, okay? And we're going to continue that next time too, next section. So here's an example. Here's f of x equal x cubed plus x squared plus 1. Okay? Now, if you were to plug in an x equal negative 2, okay? It's a pretty safe thing to do because when you plug in x equal negative 2, what's x cubed? Negative 8 plus what, x squared? 4 plus 1? Okay, 5, so it's plus 5, negative 8. That's a negative 3. So it's negative when x is equal to negative 2. But when you go to negative 1, what's negative 1 squared? Again? Negative 1. Yeah, I said it wrong. Cubed is negative 1. Squared is plus 1. Minus 1 plus 1, 0 plus 1 is positive. So it's positive when x is equal to negative 1. There's got to be a 0, at least one 0, in between x equal negative 2 and x equal negative 1. So it follows from the intermediate value theorem, there must have at least one real 0 somewhere between negative 2 and negative 1. And it says it's shown below, but it's shown on the side. Okay? Here's negative 2, negative 3. That's what we figured that one to be. And here's negative 1, 1, which we figured this one to be, x equals negative 1. Yep, you got to have a 0. There's no way you can do it. Any continuous function is going to have to cross at least one place in between that. And that turns out being the only real 0 for that function. Okay? Now, how do we get it? That's yet another problem. We'll handle that later. How I would try would say take a value in between those, like negative 1.5, okay, and plug it in and see what you get. I'd use a calculator for that one. I don't do that one very well in my head. And see, does it come out positive or negative? If negative 1.5 comes out negative, then you know you're in between negative 1 and negative 1.5. So pick another value in there. If it comes out positive, then pick one between negative 2 and negative 1.5 and go for that. So you just bracket it and zoom in on it, trying to find that 0. That's one way to do it. Or you use your graphing calculator, it'll do it for you, okay? Much easier doing that way, but you can do it and get pretty good results, okay? By continuing this line of reasoning, you can approximate any real zeros of a polynomial function to any desired accuracy. And that concept is further demonstrated here in example 6, top of page 131. Okay, there's the one we just had. Use the intermediate value theorem to approximate the real 0 of this function. Now, we've already done the main part. We know the f, whoa, get my pen set up. Okay. We know that f of negative 2 is equal to negative 3. And we know that f of negative 1 is equal to 1. We already did that, remember? Okay. So, yes. Oh, okay.
That's a different.
Oh, is it different? You're right. The other was a plus, wasn't it? Yeah, sorry. We don't know that. Okay. So, use the intermediate value theorem to approximate the real 0 of that function. Okay? Now, I always start with something I figure is fairly easy. What's the easiest x to calculate? Second? 0 by far. And what does that give you? 1, a positive value. Now you ask yourself, no. Which way do you think is more likely to be going negative? Going to the left or going to the right? Again, think of this, your end behavior here. What kind of end behavior does this function have? All right, not an end behavior, okay? I think you knew it, okay. What is happening to this function as x gets very, very negative? It goes positive? Let's take out like a negative 10. Negative 10 cubed is? Negative 1,000, okay? Okay. That sounds pretty negative to me, right? Don't want to be negative with Brianna coming in, but all right. Anyone else come in since I'll go? Okay, I think it's going negative to the left. Go to the right, what do you reckon it's doing? Yeah, it's going positive. Just take a 10. 10 cubed is 1,000. That's pretty positive to me, okay? So, since you're going negative, going left, I would go left of 0. Give me a value left of 0. Negative 1 sounds like a good one, so let's try f of negative 1. Now what's negative 1 cubed? Well, I'll write it out. Let's see, negative 1 cubed minus, goodness gracious, this thing is wacko. Negative 1 squared plus 1. This is really bizarre. Okay. What's negative 1 cubed? Negative 1. And what's negative 1 squared? 1. But minus a 1 is another minus 1. Plus 1, what does that equal? Negative 1. Ding, ding, ding. We have a positive value x equals 0 and a negative value x equals negative 1. What does that tell us? Has to be a 0 somewhere between 0 and negative 1. Want to make a guess? Negative a half. Sounds like a good choice. So let's do f of negative. I don't know, do you prefer fractions or decimal? Decimal. Okay, let me erase the fraction then. I was kind of, oh, the eraser's not working. Okay, now it is. Okay. 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 And that would be, this is so wacko. Negative 0.5 cubed minus a negative 0.5 squared plus 1. What's negative 0.5 cubed? Anyone know? Negative 0.125. And then negative 0.5 squared is? Okay, that'll be a minus 0.25. Now, the point, this thing right here is positive, but the negative sign makes it negative. Okay? And then you add a 1 to it, and what do you get? That is negative 0.375, so this will be a positive 0.625. Is that right? I'm doing it in my head. Help me out. Okay. Is that right? Okay. With a rounding support there. Okay. I think that's right. Okay. So now we know at f of negative 1, you're negative. But f of negative 0.5, you're positive. So let's bracket that. What's a value in between negative 1 and negative 0.5? Between negative 1 and negative 0.5. Yeah? Between this value and that value. Say again? 0.7. Let's go for 0.7. Okay? So we'll do f of negative 0.7. Okay? Believe we will need some calculator help on this one. That would be negative 0.7 cubed minus 0.7, negative 0.7 squared plus 1. Anyone? Calculator give you what negative 0.7 cubed is. Negative 0. Anyone got it? 0.7 cubed. Okay, say it again.
Negative
343. We'll round it there. Okay. And then we have a minus, and even though that's a minus, it's 0.49. I can do that one in my head, plus 1. Well, those two still add to be less than 1. Okay, so this will be a negative 0.833, right? Plus 1, and that would be 0.166. Right. So we're positive again. Okay? So this time we'll pick a value between negative 0.7 and negative 0.1. Because this is negative, that one's positive. So give me another value between negative 0.7 and negative 0.1. Yeah, that's what I would guess. So let's try f of negative 0.8. Okay? And that would be negative 0.8 cubed minus a negative 0.8 squared plus 1. And someone help me with negative 0.8 cubed. 512. Okay. Minus a 0.64 plus 1. This time the negatives have outweighed the positive, so now you get a negative answer. Okay? And that will be a negative 1.152 plus 1. That will be a negative 0.152. Okay? Now, as you'll notice, we're getting closer and closer to 0. This is off by that amount, this is off by that. Not getting closer very fast, but we are getting closer. What would you want to try? This time we'll go something between this one and that. Those are the two. Yeah, negative 7.5. Okay? Yeah, negative 0.75. Yeah. I'm sorry, I said it wrong. And we can keep doing that and bracket. Okay? Find the one above it and one below it, and then take something in between. And let's see, without going much further, they say continue the process until you get x equal negative 0.755. So we would have been pretty close by that one, but that's to the nearest thousands. Now, using your calculators, graphing calculators, you'll get there much, much, much quicker. But that's sort of what they do. All right. Ooh, there is a checkpoint here. Please go and do the checkpoints. There is in your margin. Why is this shutting down? This has been weird all morning long.